Question 5.41. A force given by f of x equals 5x cube in Newton per meter cube acts on a 1 kilogram mass moving on a frictionless surface. The mass moves from x equals 2 meter to x equals 6 meter. In the first part of the question, we need to find how much work is done by the force. So let us first write down the value of this force. We get f of x to be equal to 5x cubed. And we need to find how much work is done by this force when you move the mass from x equals 2 meter to x equals 6 meter. Now work done by a variable force can be given as integral f dot dx, where you integrate this over the initial and final values of x. Now substitute the values. We have integral initial x is 2, final is 6, f of x is 5x cubed dx. So we take the 5 out of the integral and we get integral to 6x cubed dx. So we get work done to be equal to 5. Integral of x cubed is x to the power 4 over 4 from 2 to 6. Now we substitute the limits. So you have to do upper limit minus the lower limit. So we write 5. First, in place of x, we substitute the upper limit, which is 6. So 6 to the power 4 over 4 minus. Now in place of x, we will substitute the lower limit, which is 2. 2 to the power 4 over 4. And when you solve this, you get work done by the force to be equal to 1600 Joule. In part B, the question is asking you, if the mass has a speed of 2 meter per second at x equals 2 meter, what is its speed at x equals 6 meter? So here the value of the mass m is 1 kilogram, and they have given you its speed at 2 meter, which we will call its initial speed to be equal to 2 meter per second. We need to find what is the final speed, v. To solve this, we are going to use the work kinetic energy theorem. We know from work kinetic energy theorem, work done is equal to change in kinetic energy. So we can write the work done to be equal to K final minus K initial. We know that we can write kinetic energy as half mv squared. So I will write work done to be equal to half mv final squared minus half mv initial squared. Now half m is common in both the terms on right hand side. We can take it outside and put the rest of the term inside the bracket, v squared minus v initial squared, that is equal to w. We need to find what is v final. So let us rearrange the term. I'm going to multiply with 2 on both sides and divide by m. So when you do that, you get 2 times the work done divided by the mass m equals v final squared minus v initial squared. Now move v initial to the other side and we get v final squared to be equal to 2 times the work done over the mass m plus v initial squared. So v will be square root 2 times the work done over mass m plus v initial squared. Now let's substitute. We get square root 2 times 1600, which is the work done we found in part A, over the mass m, which is 1, plus v initial, which is 2 squared. And when you solve this, you get the final speed at 6 meter to be equal to 56.6 meter per second.